Welcome back. Last time we were together, we were doing some preliminary work on looking at the relationship between horsepower and how long it takes to do the quarter mile in a particular vehicle, and we were using the built-in data set MT cars or Motor Trend cars from 1974. And we looked at the relationship between horsepower and time to do the quarter mile, and we saw that there seemed to be a negative correlation between those two. And we saw that visually, and we also calculated that algebraically. And now we're going to go ahead and we're going to build a linear regression model to describe that relationship, to quantify that relationship. So a linear model comparing horsepower with time to do a quarter mile drag. So we are going to go ahead and create an object. We'll call it MTC model gets, and we'll use the LM function, which stands for linear model, and go ahead and choose what we want to see here. So we want quarter mile. So in that case, it's the quarter second. So that's our dependent variable, the thing we're trying to predict. We'll use the tilde to give us essentially the equal sign for the model. And then in this case, we're going to be looking at horsepower. We'll specify the data set that we want, which again, we had chosen as MTC. Now, if we go ahead and run this, we won't get any output, but we will see up under the environment, if we look at that, that we do actually have an object there. Now, if we just look at the MTC mod, what we see here is now we have our model. We see there's the intercept, and we see there's the horsepower. So we see that for every increase of 1 horsepower, it decreases the amount of time it takes us to do the quarter mile by 1/100th of a second. And we did this just by typing in that particular model. If we want to look at some of the summarization of that output, we'll just use the summary function, which is an incredibly helpful function, and we can apply that to just about any object in R, and it will give us summary information that is appropriate to that particular object. So in this case, we see here's our model, and you'll notice that here we have the intercept, and what the estimate is, what the parameter estimate is 20.55, exactly what it was up here. And we have for horsepower, the coefficient is minus 0.1848, which is exactly what we had here. So in regression terms, this is the beta naught, this is the beta 1. The first thing, now there's other things that we can do to evaluate this. This is the summary function. Some people are more comfortable with just looking at the ANOVA output. So if you're the sort of person who is more comfortable with an ANOVA evaluation of regression, then you'll see here that you've got the analysis of variance. And perhaps I'll make another video at some point comparing the analysis of variance to the summary. But for the summary table, this is the output from that summary command. The first thing that we want to look at when we do a linear regression model is the p-value associated with the f statistic. And this is essentially telling us if the model is any good at all, if it is better than any sort of random guess. In other words, if it has any value at all, or if it's just no better than just a completely random guess. And in this case, that p-value is quite close to 0. So in this case, we're going to say that, yeah, our model does have some benefit. It does have some value. Moving up, we see the adjusted R squared. Again, I'm not, in this video, I'm just showing you how to do this in R. I'm not going to be talking too much about the particular measures and how we evaluate a model, because I'm assuming that you have some familiarity with that. So your adjusted R squared is 0.85 here. The residual standard error is 1.28, and that's on 30 degrees of freedom. You may recall how many observations we had in our data set. Up here, it does give you a quick summary of the residuals. There are other things that we can do in R that will show us the residuals in a lot more detail. But at this stage, we're really just, this gives you just sort of a highlight. And we can see that it's more or less centered around 0 and more or less symmetrical. The next thing in the summary, of course, is your standard error and the associated p-value, both of which are well below, or very close to 0, well below most thresholds that we'd use in this application. And that's the p-value associated with the t-test. And then, as before, we have our estimates. And the thing to notice here, especially with horsepower, is that that sort of makes sense based on what we saw here in the chart itself. So that's just a really quick introduction to how to fit a linear regression model in R. Also, a quick overview of some of the diagnostics that you get out of R. The ANOVA table, I didn't really talk about that, but if you're comfortable with an ANOVA table, as you can see here, you've got the degrees of freedom relative to the variable, in this case horsepower, the sum of squares associated with that, as well as the residual sum of squares, and then of course the F value. And it should be pretty straightforward to see the connection between the analysis of variance table and a lot of the summary stats here. Again, if you're familiar with linear regression, those connections should be obvious. If you are interested in learning more about that, feel free to put a comment below, and I will perhaps put together a video where I talk about those connections. Well, that's it for now. It's a short one. Thanks so much for your kind attention. If you have found this helpful, I invite you to look at my other videos and perhaps even subscribe if you're so inclined.